Okay, just want to talk about 2020 paper 1, question 6 that I've been asked about. I'm hoping that part A you can do. Um, and let's just imagine it doesn't, but let's just imagine that you were asked where does the first maximum of this occur? And I know that traditionally I've asked you to do this, where you say, right, for sine x, the first maximum occurs there, and it is 1. But then we do function transformation. So we say, okay, if you replace x with x plus 1.07, then the graph moves backwards 1.07 radians. Now this is pi over 2, which is about 1.5. So it means that the peak will be sort of here. And that value there will actually be pi over 2 minus 1.107. And similarly, the peak was 1 when multiplying by root 5, so it now becomes root 5. And that still works, still really, really straightforward if you're asked for the maximum. I note that the marks scheme uses a slightly different approach, and again, you're not asked it in this question, but so there's a different approach to say, right, sine reaches its first maximum at pi over 2. So its first maximum occurs when this thing here is pi over 2. Now we're being asked about sine of x plus 1.07. So the first maximum will occur when all of this equals pi over 2. So that maximum occurs when x is... Now obviously that's really the same approach, right? That's not a different approach. But if you've done this question, you'll know the next part is particularly tricky, and maybe this approach to say, right, so sine reaches a maximum when this is equal to pi over 2. You'll know that this helps. We'll have a look at the second part in a minute. Of course, if it had asked for the second maximum or the first minimum, then we would have just done exactly the same, but with 3 pi over 2 or 2 pi plus a half, 5 pi over 2. So, we can do this for not just for the first maximum, but for any point on the curve. So let's have a look at the rest of the question. So we're then given this rather nasty function, and we're asked about the maximum temperature and the time of day when that maximum temperature occurs. And we are told that t is minutes, and that's from 0 to 24. Well, firstly, let's see the link between the two questions. This thing here looks a lot like this thing here. The only difference is the x has been replaced with this rather horrible looking thing. So that's the first thing. And the second thing to note is that we've got a 5 added in there as well. So if I just look at this thing here, we rewrote this as this. So I can rewrite that as root 5 sine of replacing x with this. Not forgetting you've also got the Now, using my graph approach, it's really complicated to go from the graph of sine x to this graph here. I mean, minus 3 plus 1.107 you can do. But using this alternative approach to say, right, okay, the maximum value of sine first occurs when this thing is equal to pi over 2. So all I need to do is to say, right, what value of t, when does that equal pi over 2? So we do and then solving that, we can divide by pi straight away, multiply both sides by 12, sort out the numbers, take those away. You get the value of t, which I think is easier than the way I've shown you previously, which would be to take the graph of sine x, to do the shift, to multiply by pi over 12, etc., 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 which is a really complicated set of transformations. So the alternative approach for answering questions like this, when does the maximum occur, is to say, right, I know when the maximum occurs for sine x. That's when it's pi over 2. So this will reach a maximum value when x is pi over 2. So all I need to do is to work out when does that equal pi over 2. In terms of what that maximum is, well, we know that this thing here, well, because sine of anything will only be between 1 and minus 1, this thing here still has a maximum of root 5. So if we add to that, add 5 to that, then we will get a maximum of 5 plus root 5. So the maximum value is 5 plus root 5, and that occurs at the value of t you get from solving that equation there.